Hello and welcome to designTimber 2025. My name is Bryony Bodymead. I'm the Editorial and Events Coordinator at Timber Development UK and will be your host for today's webinar. This is the fourth series of designTimber webinars, which provide a platform to learn directly from the multidisciplinary design and delivery teams behind incredible timber projects collected from the Wood Awards 2024. The presentation today will focus on a small but very special project that utilises homegrown sweet chestnut to create a contemporary extension to a Grade 2 listed house in Somerset. While people are still joining though, I'll take a couple of minutes to tell you a little bit about Timber Development UK. TD UK was formed in 2021 to bring together and support the entire UK timber supply chain. We represent everyone from supplier to specifier, including architects, engineers, contractors, craftspeople, and all points in between. Here you can see TD UK's three key missions: to connect the supply chain, lead best practice, and accelerate a low carbon future. One of the many ways that we seek to deliver on these is with events such as these designTimber talks, through which we hope to educate, inform, and inspire designers and other built environment specialists to build better and lower carbon using intelligent timber design. Projects that show that low carbon future of design and the opportunities for timber are highlighted in the Wood Awards. The Wood Awards 2025 are now open for entry until the end of May. So if you just go to woodawards.com and upload your entries, and we look forward to seeing you next year. As well as webinars, if you go to the TD UK website, you'll find a wide range of other timber knowledge resources. This includes Designing Timber, our regular print magazine, a library of technical case studies, including one on today's project, and our timber knowledge sheets, which cover essential topics such as fire-safe design, timber connections, and the use of SIP panels. While many of our resources are available to all, there are lots of benefits to becoming a member. For those of you who are not already, we'd love you to join us. Not only does this benefit you and your business, but it also supports us to continue to put on free educational events like this one today. And now I would like to introduce our speakers for today's webinar, who are going to tell us about this project, Old School House. We're going to hear from George Dawes, co-founder of Bindloss Dawes Architects, Joe Garbett, Associate Director at Momentum Structural Engineers, and Tom Compton, Managing Director at English Woodlands Timber. After a presentation from each of our speakers, we'll be able to ask audience questions. So during the presentations, please do make use of the Q&A feature, which you can find at the bottom of your screens. And I will now hand over to George. Thank you.
Hello, I am George Dawes, and I'm, as you said, co-founder of Bindloss Dawes Architects. We are a small architecture practice in Somerset, in Bruton, which is where this project took place. We are doing more and more projects now in the countryside. We originally did a lot of work in London, sort of building up a nice rapport with sort of local builders and craftsmen, and doing a lot of work in timber. The more we spend out here. Joe, do you want to quickly introduce yourself as well?
Sure. Yeah, thanks, George. Yeah, I'm Joe Garbett from Momentum, Associate Director. Yeah, we also do a lot of timber design, and yeah, looking forward to talking more about the project.
Thanks, guys. Yeah, my name's Tom Compton of English Woodlands Timber. We've been milling timber for 40 years or so on our site we're located in South Downs National Park. Yeah, looking forward to showing you with our little journey of sweet chestnut for this project.
Thank you all. That's great. And then George, if you'd like to share your screen, it'd be great to.
Yeah. Okay. Can you see that? Okay. Yeah. Okay. So I'm going to give a presentation. I'm just going to give a little introduction about the project, where it is, how it came about, and some of the key kind of design decisions, and then a little bit more, then focusing on some of the detailing, which was a very important part of this project, and the general construction, how it was built, some of the sort of compositions of materials, And then I also wanted to talk quite a lot about how the building is starting to weather as well, which I think is something that's quite important with timber. And certainly when I started this project was one of my main concerns, and it was trying to make sure that it weathers well, and managing the sort of client's expectations in the sense that what will this building look like over time, and is there a point where it starts to sort of kind of gain some sort of settle. So starting off, just so we're located in Somerset, sort of where that dot is there, which is just sort of quite close to the Wiltshire and Dorset borders. And the site is in this very idyllic sort of bucolic setting in the middle of a valley, just outside the town of Bruton, close to a church there, St Leonard's. And the house was originally, or sorry, the building was originally built in 1836 as a school, serving the local community. And it sort of it was it's believed to have come out of the office of G. Street, who was a kind of very renowned Victorian architect who specialised in school buildings. And it's made from the local Hadspen stone, which is quarried sort of within 5 miles away. And then it was turned into a house in the 1940s. And it's a very nicely proportioned sort of singular building, very nicely detailed, a lot of stonework, obviously. And it was important that whatever we did was sympathetic, both to the building, but also this incredible setting, which is sort of in the middle of the countryside. Now, on the back of the building was an extension that was put on in the 70s, which I think ever since it was turned into a house, that the owners were always struggling to make it work as such. And this extension on the left, which shows what was built in the 70s, was contained 3 bedrooms and 3 bathrooms, but it was very pokey. Although you initially look and say, well, it's the same material and it seems sympathetic, the shape of the building didn't really match the sort of single-story nature of the original schoolhouse. And also it was riddled with asbestos and had various issues with it. Internally, as I said, the spaces were very pokey, and the client came to us initially just to try and resolve some of the internal configurations. And as we got more and more developed with it, we realized we sort of needed to start from scratch. So the proposal was to demolish the 70s extension, which was a kind of useful process because it basically allowed us to go back to the original school building, which are these 2 elements. And then early on came up with this idea of basically producing something that mimicked the original school house building, the main part of the schoolhouse, but so it had the same sort of massing, the same height, similar eaves, similar floor plan, but that it was clearly a contemporary extension, unlike the extension in the 70s that sort of was a sort of almost looked like it belonged in terms of its material and its detailing. This is clearly contemporary, so that it's read as a later extension. Sorry, it's got to... So this is the plan of the original building. The red was the 70s extension, and you can see how it sort of overlapped the original building in a sort of slightly unsatisfactory way. And the idea with the new extension was to sort of come away from it slightly. There was still a link building, which is this sort of section here, which is quite glazed and there's a flat roofed element that's sort of more diminutive in its appearance. But that the main body of the building is read as a sort of singular piece that sort of stands alone. And in terms of the section as well, the original building is above. You can see the sort of the high eaves, and the challenge was just to try and keep the building lower, so it had the sort of the sense of being a single-story building, although it had to contain still 2 stories worth of bedroom and bathroom. So it's sunk in its lower section. So the foundations are in concrete with concrete wall upstands around it, and then on top of that is the timber building that sits over the top. And so this was a model that we developed, kind of trying to take this very simple form and actually work out how to sort of compose windows and create a kind of composition that both served the internal spaces and also kind of worked on the outside. And what's quite unusual about this, in the sense that when you're normally asked to do an extension, it's normally for a new kitchen or a new living space. And here what's unusual is the extension is actually the bedrooms. So unlike most extensions where you end up with kind of large expanses of glass, there are lots of smaller individual windows that serve lots of different rooms. And it's really about sort of making sure that the internal spaces kind of capture that 360 quality of the site and really sort of utilize that. So that's a little background about the design. And the other big move, obviously, was what to make it in. And we settled on timber quite early on. An obvious alternative was stone, but stone is more expensive, and although it's locally quarried, it's sort of less sustainable than timber, obviously. Weirdly as well, I think timber is more contextually suited as well, because if we picked the same Hadspen stone, that would have been quite orange for many years before it started to weather and sit sort of comfortably next to the original building. So what's interesting about using a timber is that it can, over time, it can weather and silver to a similar tone and color to the original stonework. So, as I said before, the building itself was very, the sort of shape of the building was very simple, and the desire was to do the whole building in the same material. So it had a kind of singular contemporary quality, but then how to break that down, how to break that massing down. And that was where a lot of work was done, testing different cladding combinations. And we settled on this this idea of using vertical cladding on the upper story and the roof. It was important on the roof that you had vertical cladding so that the water could go in between the cladding panels and dissipate into a sort of a hidden gutter, and then flipping that onto on the lower portion, taking the same sort of rhythm and then sort of inverting it, both in terms of its orientation, but the smaller elements projecting rather than sort of being gaps between. And these are there's a site photo there sort of as it was first going on, and I'll come back to that in a second, and then in its final version. And the junctions and detailing between windows and corners was very important in terms of trying to get that precision and that sort of crafted quality. So this is a plan detail of the upper floor, first floor. And I just wanted just to show this in the sense just to talk about the sort of the composition of the superstructure. So apart from the sort of concrete foundations and base and a little bit of steel, which Joe will talk about in more detail, it's mainly timber, both in terms of the cladding, but also the superstructure. And that superstructure is basically ends up with a sort of a sandwich of OSB board with insulation and structural members inside, and then OSB board on the outside. And internally, we had a vapor barrier which was formed using insulation back plasterboard, and then on the outside was a breather membrane, so that any moisture that does get in can escape out on the outer side of the building. And then cladding with the timber directly on the outside. And what you can see here, because this is the upper story, you can see a vertical batten running down, so basically in the direction that water would need to run if as it comes through the rain screen cladding, a horizontal counter batting to support the vertical outer cladding that then sits on afterwards. And you can see in the central section detail here, you can see the vertical cladding on the upper level transferring to the horizontal cladding on the lower section, and how it kind of, because you have a counter batten on the upper section, it sort of facilitates this little step, which is quite a nice element as well. So in terms of just a few construction photos, just to show you some of that stuff that I just mentioned. So there's the timber frame with a little bit of steelwork on the left-hand side, and then internally framed out with OSB board, creating this OSB is on the inside and on the outside. And then on the outer skin there is then the breather membrane on the walls, which is a Renolit product, Alcor plan. And then on the roofs is a slightly up-spec'd version of that product, which is called Alcor Solar. And what's quite interesting about about that is that I've got a little sample here. I don't know if you can see, but this is something that's typically used for supporting solar panels, and what it allows you to do is it's you can hot weld back to the damp proof membrane, and it means that you don't perforate your roof surface, which is the surface obviously which is going to receive a lot of moisture, and then you can plant your horizontal battens, and then you can put the cladding over the top for the roof. And these, when you have an open screen cladding like this, it's very important that the membrane is UV resistant as well. So just showing you this as well. This you can see here how the gutter's incorporated, and then everything is then clad over the top. So when you once it's all covered back up, that all disappears, and getting it set out carefully to create these kind of very crisp corner details was really important to us as well. This is a view just after the roof went in, actually, and I was up on the scaffolding, just seeing the top ridge detail, and because this sort of up-spec damp-proof membrane isn't breather, you have to vent it at the top. So that's what that little detail is showing you up there as well. This slide is just to talk about how we fixed the timber. So on the left was a sample panel. We were trying various ideas out. We settled for the one on the left in the end. I'm trying to zoom in a little bit, but basically it was a combination of a diagonal nail gun coming in on the side, and then a vertical, and then a nail gun through the face. And what's going on this one, as opposed to these on the side, is that the nail gun was set so that it didn't perforate and split the face of the timber. It means you see the piece of stainless steel, but it's because it's stainless steel, it has a similar color, and actually it's almost interestingly it's less visible than had we than had it gone through the timber. So that's just a little bit about the fixing, and you can see here as well actually that composition between the different type of cladding. Sorry, let's go to the next one. This is a sort of detail axo we did after we finished the project, just to sort of communicate some of these details and how they all came together. Sorry, just put that there as well. It's not going forward now. Oops, what's going on? There we go. So that's the final photo, so you can see the two together. But it just sort of shows that composition of how those details come together to form the whole. This is just obviously a photo of that end elevation. What's very important is obviously the setting out dimensionally and making sure that the spacing and the rhythm of the timber worked with the windows and everything else. And what was quite good about this cladding layout is that we could use the gap between the cladding as tolerance to basically allow ourselves to set it out on site carefully. So for example, I think the gap between the cladding is 15 mil, but in some instances it dropped to sort of 14 to sort of accommodate slight adjustments on site. This is a little bit about the timber windows that we used. It was very important to us that they weathered at the same rate as the cladding. Quite often when you specify timber windows and they come from a manufacturer, they insist on them being lacquered for guaranteeing purposes. So we had to get these made by a joiner, and they came and they used the same timber as the cladding, which came from Tom and his team, and it's meant that the timber has been able to weather at the same rate and has the same coloration. And this is an example of what can go wrong if you insist on if you go down the lacquer route, in the sense that on the top image just shows differential weathering between a lacquered window system and the cladding which isn't weathered, which if that's the effect you want, that's fine, but it's just understanding that happens. And then the bottom slide just shows how the lacquer tends to then split off over time, and then you get this very sort of variegated weathering pattern that takes place. So just zooming back out now, so this just comes back to that point that I mentioned earlier about how the timber has started to sort of settle in tonally to the original building. but also to the wider context and the church. So that's what worked very well with the timber, in the sense that it sort of suited the landscape. Just quickly, a couple of slides. We also did a bit of timber internally. This is a timber staircase, also made in chestnut. That's obviously planed and finished, and so has a different quality, but just kind of a bit of timber, a bit of chestnut flooring as well. Quickly on the interior, it's less relevant today, but just to say that the client is the color curator at Farron Ball. So what she spent, she sort of very much took over the interior design, and what worked quite well is that while the outside of the building was the single material, the inside became much more animated, and each room took on a different personality. Okay, this is now just talking. This is our time lag now, just about the project. So this is the original building as it was in 2018, when early on, when we first sort of took on the job, and post demolition. And this is the primary structure here, with the steel ridge beam and beginnings of some other timber structure coming in. The structure building up here. This is actually just a protective layer. And the next slide. So this is the Renolit system forming the roof covering. The horizontal battens timber battens that then run lengthways. The structure starting to come in, and then the cladding going over the top. What's also included here, so this is it, sort of fresh after the scaffolding came down. It's interesting to know how where the scaffolding was, you see little bits of sort of dirt settling on the timber from where you can see across here. That was the level of the scaffolding, so that was sort of something that was kind of unavoidable. And then how over time it's sort of started to weather. This is now, I think, about 14 months, I think, after it was completed. And how it's starting to go silvery, and it was a particularly nice moment actually at this there. This was after some heavy rain, and this just demonstrates how the building changes and can there's an unpredictable level to it. And then this is a little bit after it sort of came back and had that similar quality. But this is we've now had another winter, so I'm keen to go back and kind of keep on taking pictures about this. Done a similar sort of exercise looking at the details as well. So here, roughly the same view, about, I think it's about 6 to 8 months apart, and just sort of starting to show how the building weathers. And the upper section, the vertical panels, have sort of weathered quite universally, but how below, when you get these horizontal protrusions, obviously you get differential weathering, which actually is quite a nice thing, I think, but just to be aware of it. This is one of the areas that I was quite worried about, was that when we designed these windows, they didn't have much of a slope on the lower section, and when they first went in, they went quite black, and that we were considering sort of going back and trying to sort of sand off the tops to create more of a slope to encourage the water off. And you can see actually there's a little bit of darkening there. But actually, it wasn't a problem, and in time that didn't matter so much. But I think if I was to redetail this again, I would, in general, add slightly more gradient to all horizontal surfaces, just to make sure the water comes off. This is a typical corner detail here. So this is where the vertical panel meets the horizontal panel, and the same view again. You can see here how the idea of the horizontal on the corner, that we alternated the cross as you went down, so you got this kind of tied in detailing. I just wanted to finish with a kind of a sort of word of warning in a way. This is a project that we were doing alongside at the time, also in Somerset, also from chestnut, and we experienced quite a lot of tannins coming out of the chestnut. And it was quite shocking when it first happened, and it wasn't as we expected. And this is actually a much more, this is for a sort of a garage and workshop, is much more open weave, the cladding here, and the rain got behind and it sort of washed out very quickly. And the difference here is we've got this high concrete upstand, and the face of the concrete is flush with the timber, so very much the water fell directly onto the concrete, and sort of you got this sort of tannin staining on the concrete, which kind of we didn't expect it, so it wasn't what we wanted, but it was kind of interesting. It's sort of something that maybe we could have adapted a bit more. The good news is it all washes off in time, so it's nothing that stains, but it was a shock at the particular moment. And that is my last slide, and just to show we didn't have this problem on this building, so that was good news. Just to say, actually, what we did, we slightly adapted the detail actually when we discovered that, and we set the concrete back in a little bit more so that it wouldn't come straight onto the concrete. So that is the end of my presentation.
That's great, thank you, George. And just a reminder to the audience, do put any questions in the Q&A and we can pose them to our panelists at the end. Thank you so much.
Brilliant, thanks, George. I'll just share my screen. Great, hopefully everyone can see that. So yes, it's yeah, just want to say thanks to Timber Development for asking us to speak on the project. And yeah, thanks, George. It's a wonderful project, and I think what's really interesting about it is that the sort of having such a contemporary addition to the grade 2 listed structure is really interesting, and I think yeah, George and his team have done an amazing job to create some really sort of beautifully and carefully considered details that create such a sort of well-crafted building. But yeah, I'm going to speak a little bit about the structural approach and a bit more about the construction of the building. So just a very quick overview of Momentum. We work across a whole range of sectors. We're based in Bath and London, and we work across arts, conservation, events, residential, education. And in all our projects, we focus on sustainable design and using low carbon materials with a particular focus on timber. So here's a very small selection of some of our timber projects. So we work with traditional green oak framing for sort of new build and heritage work, restoration of historic structures, and then also engineered and sort of mass timber structures. We've done timber grid shells and work with reclaimed timber, and also do a lot of work with panelized and sort of prefab systems, including sort of modular systems like WikiHouse. But we also do a lot of simple timber framing, which is cost efficient and sustainable, and that's very much what what we were trying to do on this project. So I think some of the key things here, one was to just achieve open spaces and really achieve the architectural vision to sort of keep the internal space as free and open as possible, and to do that with simple timber framing, and as I say, keeping that sort of as efficient and cost effective as possible. And we also had to consider obviously working adjacent to the existing grade 2 listed structure, which I'll touch on a little bit too. So here's a sort of cross section through the new structure. So as I say, it's very simple timber frame with localized steel elements that really sort of open up this space. As George mentioned, the ground floor is lowered to allow us to sort of fit 2 stories into the structure while maintaining the eaves line and the ridge line to sort of reflect the original building. So that's done using a raft slab with a reinforced concrete retaining wall, which forms this lowered structure. And And also, as George mentioned, provides this upstand, so the timber structure itself is lifted off the external ground level. I think one of the great things about this extension is actually the separation from the existing is just enough to mean that it didn't need too much work to the existing structure. We sort of kept those two things fairly separate with a very sort of simple link structure with a flat timber roof and a ground level flat slab. At first floor level, we've obviously got this very low eaves line, and we've also got the large pitch frame window on the gable end. So just thinking through sort of roof options, obviously the simplest approach is to have a sort of a tie beam at eaves level. So, you know, as you would with a sort of truss raft roof. Obviously that didn't work in this space. Alternatively, a sort of raised collar could work well, but again, that would be would interfere with this sort of internal space rather than having it nice and open. There was also thoughts on you know, whether this could be braced like a sort of crack frame approach, but again, all these sort of approaches sort of interfere with that internal space. And finally, you know, there could have been a more engineered sort of portalized frame with moment connections, but again, that's sort of adding complexity and cost. So the final approach was to have a simple ridge beam that was quite long spanning, but basically ran along the ridge line and picked up rafters that were simply spanning from wall line to ridge. And that did mean the introduction of this this steel element, but actually then freed up the, you know, the whole first floor space to sort of really maximize those volumes. And you've seen lots of pictures of this already, but you can see the window on the gable end that we had to frame round, and the link building next to the existing, which very much sort of disappears with those build-ups. And you can just about see the concrete upstand as well to the perimeter, which is formed by the retaining wall. And I think on this project, it was about 250 mil that the timber was above external ground level. So yeah, just to show you some of the structural arrangement. So this was sort of lower ground floor level. So you can see the raft slab there with the perimeter retaining wall, which had a land drain to the perimeter. And then you can see the internal structural walls starting to rise from that point. So because we had this external concrete structure, it meant we could actually internally run the timber, the structural timber elements right down to ground floor level. Then this is sort of ground floor level, so top of that retaining wall and sort of ground floor level for the link beam, the link building. So yeah, once we're above ground level, it's sort of timber framing throughout with double studs and triple studs where we've got point lays coming into the main timber supporting structure. And again, the internal timber load bearing walls and racking panels sort of continue up to this level. And then once we're up at first floor, you can see on the right hand side, we've got the some additional steel framing there starting to form the large window and extend up to support the ridge beam above. And you can also see an additional steel there, which again is supported on the external timber frame, but allows for this step in the racking panels. So from ground to first floor, we have a timber studwork wall that runs up where you can sort of see highlighted red there. And then from first floor level, that steps across to the steel line. So it's So there's a bit of juggling in the structural system there, just to maximize the space at first floor. This steel obviously takes the vertical loads, but it also is working to transfer those lateral loads that are transferred into the timber racking panel. And so in terms of overall stability, we have these internal walls, and then in the short direction, we also have sheathed walls on each gable end. And then in the other direction, we have a continuous internal wall, which again is sheathed to provide stability in this direction. And the external walls, we did have the openings do move around from level to level, so we had to accommodate that, but you know, a reasonable amount of walls there to deal with stability. And at roof level, we've got our steel ridge beam that spans, as I say, a reasonable distance, but because we're using steel, that allows that all to sit within the roof build-up. So just a run through the construction sequence as well, quickly, because it's quite useful to sort of see how that came together in more detail. So the initial work was to form the excavation for the lowered ground floor slab, install the perimeter land drain, the ground floor raft slab, and the small retaining wall to the perimeter. As I mentioned earlier, that having this offset from the existing structure was worked well in terms of limiting any impact on the existing structure or having to do any underpinning. That it gets slightly closer to the existing building, sort of on the left hand side there, but even so, through some investigation works, we were still working within depth of the existing footing, so it meant we weren't sort of undermining any of the existing structure or having to look at underpinning. So from that point, we could then build up our timber frame. So that could be built up to first floor, and that also incorporated the steel that I mentioned earlier within the first floor structure, which would go on to support an additional sort of stepped racking panel above it. We then had some temporary propping just to support a double stud, which was quite a large sort of double stud that ran up to support the ridge beam, and the steel framing on the other gable end that worked around the window and provided support to the ridge beam over. So that meant that could all go in, and then the rest of the timber frame could be built around that. From here, we could then continue the internal racking panel that went right up to the ridge line on the left there, and build the remaining timber framed walls. We also had some additional temporary works here, so we had some temporary ties that ran between the eaves line on each side of the building, which held the walls in place before the rafters went on, and also provided a sort of a temporary platform of sorts. There was also some additional propping there. And then finally, the rest of the external skin could then be applied, as George has mentioned, and Tom will talk through in more detail. And yeah, through that approach, it meant the internal space could be maximized with with really sort of clear open spaces, and yeah, sort of create this beautiful internal space which that dog seems to be enjoying. So a few final images of the construction before I pass over to Tom. So you can see here, this is the lower ground floor slab, raft slab in place with starter bars ready for the retaining wall. And then we've got the formwork in place for the reinforced concrete wall. From there, we can then build up the timber frame up to first floor level, and you can see the steel framing going in for the ridge line. Then here you can see sheathing boards ready to go on onto the timber frame, and the temporary shoring for the timber at the far end of the ridge. Once the ridge beam was in place and the first floor studwork walls were in place, then the rafters could be installed, which were slope adjustable hangers to a timber infill to the steel web. Where the ridge beam met the timber racking panel, there's a sort of simple detail here with a sort of flitch and a bolted connection to the vertical studs. And some people are sometimes, surprised about steel elements being supported on timber frames, but as long as it's carefully detailed, it's effectively, a sort of flitch connection with a load transferred to the timber through the bolts. So relatively straightforward. Here's a quick view of the first floor level with the temporary timbers running along the head of the walls, and you can see some temporary props just supporting that studwork wall. And here's a view of the rear of the building with the sheathing starting to be installed, so you can see the external OSB boards being applied, and the internal racking panel that runs up to the ridge beam, which sort of runs full height of the building and helps with the stability in that direction. And at this point, the structural frame is near completion, so membranes are starting to go on, and for the external cladding to be installed. So at that point, I'll hand over to Tom.
Thank you. Thanks, Joe. So yeah, thanks again. Thanks for inviting us to share a bit of the story. What I want to focus on and share with everyone is how we go from a tree to a piece of wood that architects can design to and structural engineers and carpenters can affix. So it's our little story of tree to final product for us. So our journey to get some wood for construction starts about 2 years before our customer might order it. So we're actively, we create stock that's then available for people to use. We love sweet chestnut because it's so versatile. And so the journey of this particular supply started in a forest not far from here, Stansted Estate, very beautifully managed estate in Hampshire. And here another dog and myself with the forester literally selecting trees and cutting them down, ready to take to the mill. We like to cut chestnut in the winter because, in fact, all hardwoods in the winter, because the sap is down, and that allows us, that's the first, our objective is ultimately to get moisture out of wood. So if we start with it, less of it in the tree, the better. So these trees are cut, they're taken by a lorry to a mill, and their conversion process starts then. Once they're at the mill, we lay them out. Trees, funnily enough, are not straight, and chestnut particularly tends not to be straight. And so usually the longest lengths that we can cut, or we cross cut, is between 2.5 and 4 meters. And that's just the natural form of the tree, how it grows. And that fundamentally can be a limiting factor in your maximum length. As it turns out, on the roof, 4 meters was just about what we needed, but that's usually the maximum length in solid sweet chestnut. There's a couple of the guys. These guys actually, they did the whole thing. They felled the trees, got them out, and here they are admiring their work. For cladding purposes, we are cutting a thickness of 27 mil, and we cut that into a waney edge form. To get a decent width board, you need about a 40 centimeter wide board. That means the tree roughly is going to be a minimum of 45 years old. And we choose that thickness to give us the maximum yield, but also to allow a little bit of air shrinkage as the tree loses moisture. Most cladding finishes are about 20 mil, and we, from a sawn board, we're allowing maximum about 2.5 mil per face. So that we work backwards from the finished size to a sawn size. Straight after sawing, they're put into into packs, and that allows the air to circulate on every surface. And you'll see very nice neat stacks where the weight is transferred right the way through the sticks to the bearers to the ground on a flat surface. So important to get that right, because if it's not flat, the wood will take the form, the shape that it's given, and you'll never straighten it out again. Over the course of an English summer, we are taking the moisture content down from about 50 to 60% down to about 25%, and that's then considered an air-dried state. We know that wood is hygroscopic, and so we want the product to be settled at its ambient humidity of its application. That means that once we cut it and you apply it, we wouldn't expect any movement. And as we heard from George, if you're being very precise around your 15 or 14 mil, we don't want it to suddenly disappear and make it 20 mil, or that would be a challenge once fixed. In conversion terms, we started off on this particular path with about 120 cubic meters of round wood. We get about a 50% conversion, so we end up with about 60 cubic meters of sawn board. From that stock, we can then apply it to the demands of architects and builders, and it's available to produce. In chestnut, because of the way the trees grow and how we use it, or how it's used, widths greater than 150 mil 6-inch are quite hard to achieve in a big quantity, and are in any case prone to cupping. Very nice feature of this project was that there were narrow widths, so whether George intended it or not, the utilization of the yield at that width was very, very good. We then, once the order is placed, we then take those boards and we cut them in a secondary process to size. And we're looking out for other natural defects you might have of heart, end splits, knots, brown stain, and we want to produce a clean square edge blank ready for planing or profiling. In conversion, whenever you're producing one particular size from a waney edge board, it's always quite challenging. It's really nice and helpful if you have more than one size, but that's just a timberman talking. In chestnut, the sapwood is actually very narrow compared to something like oak, which can be very broad. And so from that sawn, about 60 cubic meters, we then expect about 40 cubic meters of squarage. So we've gone from 120 to 40. It's quite a lot of conversion. Through our planing process, any final quality issues are become very evident. They're then defected and the material is ready to take to site. It's really important with, particularly in English hardwoods and chestnut, is to help. It's really important that the natural features of those woods are incorporated into sample panels or the client's understanding of what they're getting. Durability, chestnut is such a wonderful timber. English, it gets its durability from a very high tannin acid contact, and that makes it very resistant to fungal attack. But it does bleach out, and eventually that can go to a very dark color. Very important, the fixings you use, stainless steel, please. Anything ferrous will react not only to the wood itself and produce a stain, but the fixings themselves will disintegrate. Always use stainless steel with chestnut or oak in that. If you're thinking of using chestnut, just a few tips: contact us early for availability. Think carefully about your orientation. Interesting that this project had both, because that does determine the profile options that are suitable, either horizontal or vertical, to allow the water to be shed. Lengths, ideally no longer than 3 meters, but one can do longer. Think about fixed or random lengths. Fixed lengths tends to put the price up. Random lengths gives you a better yield, and therefore the cost is less. Widths, anything from 50 to 145 mil is possible. It comes out of a waning edge form. We can adapt the stock to your project. If the way that we can help builders and architects is, you tell us exactly what you need, and we'll produce it exactly what you need. So you minimize you should have very little waste. But we do ask you to finalize those cutting lists well in advance. Please don't call us 2 weeks before you're about to install with what you need. It may not be possible, or it will come at a high price. Thank you. It's a wonderful project to have been involved with.
Thank you so much, Tom, and George and Joe. Those were really, really great presentations. And I can see that you have been busy answering lots of the questions that have come in from our audience. So thank you so much for that too. And yeah, really great actually, because a number of the questions had been asking about the treatment potentially needed for the sweet chestnut, and you were explaining that they don't need to be. So it's really great in that one of those last slides of yours, Tom, explaining about the kind of natural resistance, which is why the material doesn't need to be treated. I think there are a few more that I might we've got a little bit of time to pose some of the remaining questions. If our presenters will have a little look through too, if there are any that you would particularly like to answer live, do let me know. I mean, one thing that I had wanted to ask, I guess, of probably both George and Tom, was whether there were any other timber species that you had been considering for the external cladding, and why it was that you chose to go with sweet chestnut in the end, why that was sort of seen the most appropriate option for the project.
Well, I could just start. The reason why we chose chestnut over, for example, oak or cedar or larch, which I think are the other ones that are often used. Firstly, I think chestnut is slightly cheaper than oak, and it's also more stable, I understand as well. One of the things that has been, we read up on the different qualities. There was a very good document, I think, that written by a Scottish Timber Association. I can't remember exactly where it was, but it was a very good document that talked about how to choose timbers and which ones were more suited. And we read up that chestnut was very stable, and that was important. When you've got these long pieces of cladding, we didn't want them to waver and kink. And we understand that oak isn't good for that, actually, and that some projects that have done cladding have come a cropper when they've been done in oak. Cedar is something that I've used in the past, and that's very nice, but I think that's also a little bit more expensive than chestnut. I don't know, Tom, whether I'm right in saying that.
Cedar.
Yeah.
Canadian cedar is very expensive. British grown cedar is probably slightly cheaper actually.
It's not as good, is it, as Canadian?
It's not as tightly grained.
Yeah.
It's pretty good durability, but you need to be comfortable with a more open knot sound, but open knot look.
Yeah. And just and then just to add further, the other reason for using chestnut was because it came in long lengths, and and I know we tested you with that, Tom, but the on the roof we didn't want to break those pieces of cladding. So it was important that they came in single length. So that was another consideration. Plus, it's an indigenous species, and it has a nice color as well. So there's lots of things going for it.
Yeah, we're seeing more and more people. Chestnut is I think for cladding is a better species than oak. It's not in such huge. It's not available in such big quantities because there aren't many people like us going to a forest and cutting it down. There's so much comes from so much oak, and most oak comes from Europe. But there's chestnut is not as such a voluminous species, and it is, from a milling point of view, it is challenging. You've got to know what you're buying. The tree I didn't mention, but the trees themselves, when they're growing, have a preponderance to shake so that the annual ring separates. So getting the raw material, which is sound to start with, is quite a challenge.
Thank you. And I wanted to ask, I think you might be typing an answer right now, Joe, but it's quite an interesting one to share. Question asking about the decision to build the ridge beam in steel rather than timber, saying probably we would have needed to be twice the depth if built in timber, but it looked like there would be space for that. So why was the decision made?
Yeah, agreed. I mean, I think the decision was made to keep the structure within the finishes line and sort of keep that internal space as open as possible. George, correct me if I'm wrong. But yeah, I agree. I mean, a timber ridge beam could have been used that there was space. So yeah, a sort of deeper timber ridge would have also worked, but obviously would have sort of extended into the internal space.
And there's another question about the design and how it addresses air tightness and thermal bridging. So particularly asking about the way that the steel frame sits within the insulation layer.
There is some insulation that wraps over the top of the steel, a thinner level to kind of deal with that localized point and to prevent a cold bridge. And in terms of air tightness, the strategy was to prevent moisture from the inside going into the superstructure, and so we used insulation back plasterboard and taped the joints between that in order to create a kind of an air tightness quality. But as an extension to an existing listed house, which has a lot of gaps and holes and all sorts of kind of problems with insulation, we're not trying to make an airtight building in the same way as you would as if it was a new build. So it's got a different kind of parameters. It's obviously much better than the original building, but it's part of that. It's part of the overall kind of space heating of that of the original building, albeit we created doors in between the two so that you could kind of seal them off and have them on separate heating controls.
Great. Well, thank you so much. I think we are just about out of time, but it was just, yeah, really fantastic presentation. Great to see so many of those details. And yeah, thank you all so much for taking time to show us. Is there any last thing anyone would like to say before I share a couple of slides to close?
No. Thank you very much.
Thank you very much.
Okay, so I am just going to share now and just to tell you a little bit about what we have coming up next. So Next designTimber webinar is going to be in April, which will focus on Workstack, a 5-story workspace in Southeast London. You can see some images of it here. Constructed primarily from CLT, the building stacked form offers an innovative and low carbon solution for creating high density industrial space on compact urban sites. So quite a different focus project. But ahead of that, we have a special webinar session focusing on de-risking moisture in mass timber construction projects. So do sign up for both these events next month for free on our website. And with that, I will say goodbye and thank you again to George, Joe and Tom, to all of our attendees today and your thoughtful questions. And I hope that everyone has a lovely afternoon.